So here we are back in chapter 4, video 2, and we're talking about things that dissolve in water. These are called aqueous solutions, and these aqueous solutions sometimes do one of three different things. First thing that they can do is they can form a strong electrolyte solution. A strong electrolyte solution is one that forms lots of positive ions and or negative ions, usually together. They have to be in pairs because otherwise they're not an equal solution. A weak electrolyte solution, this is one that has only a few positive or negative ions in it, or it forms a non-electrolyte solution. This is one that doesn't conduct electricity very well and would not have very many positive or negative ions in it. To know which is which, to know which, and how to illustrate them is what this video and the next one are all about. So, we're going to make a table on the next page, and you need an entire page for this, and you're going to have to turn your page this direction called landscape. But it's important to know one thing first. It's important to know that some things don't dissolve, and things that don't dissolve are not aqueous, and therefore they cannot form any of these things. We're only going to focus right now on things that do dissolve, and this table that we're going to make is going to classify things that are strong, things that are weak, and things that are non-electrolytes in solution. In other words, good conductors of electricity, sorta good, and not good at all conductors of electricity. And therefore these have lots of ions, these has only a few, these have none. We'll also talk about how to illustrate them as well. So clear your page, go to one that's landscape version like this, and then put at the top electrolyte, and then we're going to look at three different types. We're going to look at strong electrolytes versus weak electrolytes versus non-electrolytes. And the first one that we'll look at is the non-electrolytes. So non-electrolytes are also known as molecular or covalent substances. Molecular and covalent substances are ones that contain only nonmetals. If you forgot this from chapter 2, only nonmetals. So if you're looking on your periodic table, it's not that many different elements. They would contain these guys over here because these are the nonmetals. So if it's got these or hydrogen in them right here, they would be molecular or covalent substances. Some examples would be carbon dioxide, glucose, methanol, ethanol. Notice all of these contain only nonmetals, and these would not conduct electricity in solution. So things that contain only nonmetals are called molecular or covalent and are non-electrolytes. All right, let's look at weak electrolytes now. Weak electrolytes are usually acids or bases. And they're most of the world's acids or bases. These are things that contain a hydrogen and then a nonmetal. Therefore, they can be confusing. These are called acids. And they can be confusing because these non-electrolytes over here contain only nonmetals as well. And so these acids right here, have to recognize them right now for what you know, that they have an H or a hydrogen to start their formula. Most bases, or a lot of bases I should say, have a metal and then have a hydroxide connected to them, an OH right here. And these generally tell you that they're bases, and they contain a metal, and so you can separate them from the non-electrolytes. If they're a base, but they do not contain an OH, they're usually a derivative of what's called ammonia. Ammonia is a compound that is all nonmetals. Whoops, I spelled it wrong. Ammonia, A-M-M-O-N-I-A. Ammonia is a compound that has one nitrogen and 3 hydrogens. Other derivatives of ammonia are series of carbons, and then they contain an NH2. These types of compounds are called amines, and this NH2 containing part makes it act a lot like ammonia. And as we'll learn in a couple sections from now, we'll see that these species right here are good at accepting hydrogens. These species right here, known as acids, are good at giving them away. But for right now, you can just classify in your mind that, hey, if it's got an H and a nonmetal, it's an acid, and it's probably weak, except there's a few strongs you need to know. And if it's got an OH or an NH2, NH3 type thing in it, it's probably a base, and it's probably weak. Now for the strong electrolytes. The strong electrolytes have 3 categories. First of all, they contain ionic compounds that dissolve and are soluble. Ionic compounds are ones that contain a metal and a nonmetal, or a polyatomic ion and a polyatomic ion. You learned how to name and formula write these back in Chapter 2. And these are the ones that contain something usually from over here, everywhere over here on the periodic table. And these right here were special because they didn't need a Roman numeral, but these all needed Roman numerals for the most part. And then they combined with something, and we had to make sure that their charges added up to 0. So there's a special category of ionic compounds that dissolve or are soluble, and we'll learn about those shortly. There are 7 special acids that are strong. These are HBr, HCl, HI, HNO3, HClO3, HClO4, and H2SO4. You'll learn a way to say these and then memorize them, because it's the only way to know the strong acids. And then everything else that starts with an H is a weak acid. There are 8 special strong bases, and these special strong bases are also easy to remember. If you look on your periodic table, they're the hydroxides of the group 1 and some of the group 2 metals. They actually are lithium, sodium, potassium, rubidium, cesium, barium, strontium, and calcium hydroxide. And if you draw this on your periodic table this way and put a little circle in the middle like this, you can see that they form the shape of the letter B, like base. And the formulas for them would be lithium hydroxide, sodium hydroxide, following down right here, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. And then you have to be careful with these 3, calcium hydroxide, strontium hydroxide, and barium hydroxide, because they have 2 OH groups connected to them, because remember, this group is positive 2 as opposed to this group, which is positive 1. So once we know what kind of electrolyte it is, a strong, a weak, or a non-electrolyte, then we have to know how to illustrate these. And I recommend that you keep this page separate, and then you go to a new page, and you can start these next notes. We'll refer back to this often, though. So how do we illustrate these strong electrolytes in particular? How do we illustrate these strong electrolytes? Well, when strong electrolytes dissolve, they dissociate. They dissociate meaning they ionize, or meaning they split up, or they break apart into their positive or negative pieces. And if you remember back from last video cast, we said that things that break up into their positive or negative pieces are strong electrolytes and good conductors of electricity. And that's what these guys are right here. These form positive and negative species in solution, and they're also known as aqueous solution formed positive or negative cation or anions. So, for example, barium hydroxide. Barium hydroxide is a strong base. It's one of the special strong bases, and when it dissolves or is aqueous in solution, it will split up and form Ba positive 2 and 2 hydroxide ions like this. And so this is the way it exists in solution, and we can put a little AQ down below each one of these, indicating that they are soluble and form ions. They've completely dissociated or ionized or split apart to form positive or negative ions. There aren't any of these left anymore. There's only these in the solution. Here's a second example. This is 2 polyatomic ions stuck together, and 2 polyatomic ions stuck together are known as ionic compounds. And these happen to be a soluble ionic compound, which you'll learn about shortly, how to know whether they're soluble or not. And when they are, they break up or split or ionize into their NH4+, notice there's 2 of them, and SO4.2- ions. And lastly, here is a strong acid, HBr, and HBr forms ions H+ and Br-. It completely dissociates or ionizes and forms H+ aqueous and Br- aqueous. Now, technically, we're supposed to write AQ down below each one of these, but it's okay to just write the ion because it's known that this is aqueous already, and these will dissolve in water as well. This illustrating of strong electrolytes will be further explained, and we'll talk about how we use them over the course of the next number of videos.